In this video, I will explain how to find the components of a vector when you're given the magnitude and the angle of the vector. So I have two examples for us to work through here. Let's check out this first example. This says, determine the x and y components of each of the force vectors below. So for this particular vector, we're told that it has a magnitude of 15 newtons and it's at an angle of 60 degrees. So to find the x and y components of this vector, when we talk about the x component, we're talking about the direction along the x-axis. So if we say that this is, let's say, vector f, this x component we can label as f sub x. And the y component is going to be the y direction. So that's f sub y. Now to actually calculate these components, these x and y components, we can use these formulas right here, where the x component is equal to f, the magnitude, times the cosine of the angle, and the y component is equal to f, again the magnitude, times the sine of the angle. So let's go ahead and write these out. So the x component, we'll say f sub x. That's simply equal to the magnitude, which we're told is 15. So we'll say 15 times the cosine of the angle. So the angle again is 60 degrees. So we get 15 times the cosine of 60 degrees. That turns out to be 1/2. So 15 times 1/2, that's equal to 7.5, and we'll say newtons. So the x component for this particular vector is 7.5 newtons. Now to find the y component, let's write that down, f sub y. That's also equal to the magnitude, which again is 15, but now we do the sine of the angle, so sine of 60 degrees. So the sine of 60 degrees, that turns out to be the square root of 3/2, or as a decimal, it's about 0.866. So we'll say 15 times 0.866, and that turns out to be about 12.99. And again, we'll say newtons. So the y component of this vector is 12.99 newtons. Okay, now let's check out our second example. So we have this vector here, which we're told has a magnitude of 44 newtons, and then we're told that this angle right here between the vector and the y-axis is 30 degrees. So again, we're going to use these equations to find the x and y components of this vector. But what we need to know is that when we're measuring the angle, so the angle that we should use, we have to start at 0 degrees right here along the x-axis. And then we have to work our way around until we end up at the angle right here. So what would this angle be? Well, from here to here is 180 degrees. And then if we wanted to get all the way to the y-axis again, that would be another 90 degrees. But we're going to stop 30 degrees short of that. So this is actually, this little angle right here is 60 degrees. So altogether we have 180 plus 60, which is 240. So this angle is 240 degrees. So this is the value we're going to use when we're actually calculating these cosine and sine values. Now, if you wanted to, you could also use the negative angle. So if you instead started right here at the x-axis and worked your way here, you would find that this angle is negative 120 degrees because it's 90 degrees to get right here, and then an extra 30 is 120. So if you used negative 120 degrees, you would get the same answer. So you can use either one that you'd like. For this example, I'm going to use the positive angle of 240 degrees. So first, let's start with the x component. We'll say f sub x. That's equal to the magnitude, so 44, times the cosine of the angle. So again, we're using the cosine of 240 degrees. Now, the cosine of 240 degrees is negative 1/2. So really this simplifies to 44 times negative 1/2. And that comes out to negative 22. And we'll say newtons. So the x component for this vector is negative 22 newtons. Now to find the y component, let's write that down. F sub y, that's equal to, again, the magnitude of 44. Now we do the sine, so multiplied by the sine of the angle. So the sine of 240 degrees, that's negative square root of 3/2, or as a decimal is negative 0.866. So we'll simplify that to 44 times about negative 0.866. And that comes out to negative 38.1. And again, we'll say newtons. So the y component is negative 38.1 newtons. And one thing that we'll notice about this example is that both the x component and the y component are negative. And that makes sense because if we look at the x direction of this particular angle, f sub x, so the x component, is in the negative direction. It's going left. And similarly, the y component, this component right here is also going in the negative direction. So both the x component and the y component are both pointing in the negative direction, which is why they both have a negative value for their components. So those were just a couple quick examples of how to find the x and y components of a vector when you're given the magnitude and the angle. You just need to know these two important formulas right here.